Okay, welcome to class 8, video 2. To start with, you did an argument sorting exercise and watched a video about that, and now you should have done a reading and an exercise that explained the technical terms that are applied to the patterns that should have emerged from that sorting exercise. So just to review, the easiest way to do the sorting exercise was to actually put the arguments in 3 piles. You could do a 4-pile version. We'll just talk about the 3-pile version. There are the good arguments. There are and these are the best arguments. There are the arguments that are like the best arguments, but contain false statements, false premises, and generally these were silly premises. And then there were arguments that just didn't work at all, right? That latter category we could divide further into arguments that had bad inferences and arguments that had false premises, but we're not going to do that. So the terminology from that was the idea of a sound argument, an argument that was valid but not sound, and an invalid argument. And that was the terminology that was introduced in the reading. And so the first exercise set would have had you separating valid from invalid arguments. That is, you're not worried about whether something belongs in the top pile, the sound pile, or the valid but not sound pile. So now I'm going to go into more detail about those this terminology. But basically the idea is, as I said before, there are 2 ways an argument can go wrong if you just look at the argument in itself. One or more of the premises can be false, and the inference could be weak. And I said in the previous video that this corresponds to 3 questions you should always be asking. You want to be checking the reasons. Are the premises true? Check the reasoning. If the premises were true, would they support the conclusion? That's what corresponds to the previous 2 ideas. And then, because this is a practical course, you want to be checking for missing information. Has any relevant information been omitted from the premises? So most of the rest of your reading then was actually about this middle question, trying to figure out how to, giving you terminology for checking the reasoning. And as I indicated already, the first bit of terminology here is the term valid. So I'm going to move to an earlier video where I talk more about validity and soundness, and after that we'll do some of the exercises, and then we'll get into the deeper level where we talk about strength and cogency in the last set of exercises. All right, so when we talk about arguments, classically, people have gone looking for the very best arguments. This is mostly a bit of the history of European philosophy, and they came up with this word to describe the strongest arguments, valid. And because we want to distinguish the truth of the premises from the strength of the inference, we need to distinguish valid from sound. So these are 2 separate terms we use to evaluate arguments. We're going to say that an argument is valid if it is impossible for the premises to be true and the conclusion false. That's an odd phrase, but we need to just sit with it a while and really get it down. We're not claiming that the premises are true. We're just saying that if they were true, there's absolutely no way the conclusion could be false. And then if it turns out that the premises actually are true, that's a bonus, and we say that the argument is sound. So when you check the reasoning, if the reasoning is perfect, absolutely perfect, we say that the argument is valid. If after that you check the reasons and you find that they are true, then the argument is sound. All right, remember this slide from a video last week? We defined an inference as the connection between statements in an argument. So when you move from the premises to the conclusion of an argument, you are making an inference, right? The connection between premises and conclusions is the inference. So when we say that an argument is valid, what we mean is that the inference, that connection, is perfect. So it's about the arrow. When we say that an argument is sound, we say that it's valid and, go back, the premises, here just premise 1, premise 2, they are true. Okay? So here is one of the standard examples of a valid argument. All people are mortal. Socrates is a person. Therefore, Socrates is mortal. Right? If those two premises are true, there is no way for the conclusion to be false. Also, it's sound because we know those two premises are true. Now, think about this one. This argument is also valid. All people are carrots. Socrates is a person. Therefore, Socrates is a carrot. So this is an argument that is valid, just as valid as the last argument, but it's not sound anymore. So again, an argument is valid if it's impossible for the premises to be true and the conclusion false. It's about the relationship between the premises and the conclusion, right? So there's one possibility that's being ruled out here. True premises, false conclusion. We're ruling that out. So look at these two examples again. In the first example, we have true premises and a true conclusion. In the second example, we have false premises, one false premise, that all people are carrots, and a false conclusion. Neither of those are ruled out by the definition of a valid argument, which just says the premises can't be true and the conclusion false. So both of these, that's one reason why both of these count as valid. This, on the other hand, is an invalid argument. All people are mortal. Socrates is mortal. Therefore, all people are Socrates. Right? Now you've got, we just rearranged the premises and the conclusion, and, or actually we just rearranged some of the terms in the conclusion, and now we get two true premises and a false conclusion. And so that is obviously the definition of an invalid argument. But now consider this. All dogs are mammals. All domesticated canines are mammals. Therefore, all dogs are domesticated canines. Think about that for a second. Is that valid? It already says on the top, it's invalid. It's not valid. All these statements are true, but the way the argument is structured, the premises could be true and the conclusion false. And the way to see that is to substitute in different terms. So, I see what's going on here. So, even though all the premises are true, they actually don't provide support for the conclusion. And we can see this by substituting cats for domesticated canines. Right? All dogs are mammals. All cats are mammals. Therefore, all dogs are cats. Suddenly, we have the same argument structure, but true premises and a false conclusion. So with this argument, when you look at it as this structure, you can see that it is possible for the premises to be true and the conclusion false, and therefore the argument is invalid. All right. Validity is a very special kind of compliment that you can pay an argument. It's the highest possible compliment you can pay an argument. And in the real world, most arguments aren't even trying to be valid. There are only a few contexts where we really encounter valid arguments. And these mostly have to do with kind of arbitrary systems or systems that might be viewed as arbitrary. Well, okay. Grammatical rules, logical rules, legal codes, mathematics, logical games, and puzzles. All of these are situations where we just pretend like our definitions are incredibly rigid. So if you want to know a mathematical statement, you can reason to the truth of that statement with validity. 2 plus 2 equals 4 can be proven from other premises with validity. Well, there's more complicated. Math, pure math, not math tied to the messy physical world, but the idea of pure number, this is a realm where validity is possible. Also, if we've got truths that we accept so naturally that they seem like mathematical truths, then we can go ahead and say that. So arguments with premises like all people are mortal, or unsupported objects near the earth are pulled toward the center of the earth, those all statements there are universal enough that we can say that there's a valid argument that's possible. Valid arguments are also possible in hypothetical situations if we just imagine that we've got a perfectly verified truth. So we can say, all humans have purple hair and 5 legs, or all people are carrots. As long as we're imagining that these universalizations are as true as 2 plus 2 is 4, then we can make validity possible. Okay, now that we have the concept of validity down, let's look at some of the homework problems from the first set. These are problems where you only have to say whether the argument is valid or invalid. But of course, you have to put it in standard form first before you can even judge that. So let's just run through a few of these and see how they go. So all dinosaurs are people and all people are fruit. Therefore, all dinosaurs are fruit. This should be a familiar pattern to you now. There's your indicator word. There's your conclusion. Conclusion. All dinosaurs are fruit. And it's full of silly examples. So that could mean that, well, it means it's definitely not sound. It still could be valid or invalid depending upon how the rest of everything is arranged. So we've got P1, P2, P1. All dinosaurs are people. P2. All people are fruit. Indicator. Therefore. But you can see that this has the same pattern that you generally find in, this has a pattern that you find in valid arguments, right? Essentially, you have a group of inclusive circles. You imagine this is the group of dinosaurs, and all of them belong to the larger group of people. Dinosaurs, people, and all of those belong to the larger group of fruit. It actually doesn't matter what nouns you put in here. You know this argument form is valid. So this is valid. It's not sound, but we don't even need to worry about that. Okay, let's take a look at the next one. This is another one that is conclusion end, right? All people are Socrates. And then again, the indicator is therefore. It's a false conclusion. That's still not enough to tell us whether or not it's valid. Valid arguments can have false conclusions. Invalid arguments can have false conclusions. Let's take a look at this. All people are mortal. That's true. I'm just going to make a little note. And Socrates is mortal. That's also true. But the conclusion is false. True, true, false. That is the one thing that we know makes an argument invalid. Right? So you've got silly ideas, you've got, well, actually you don't have silly ideas, but you do have a silly idea in the conclusion. But it's really the structure of it that makes it invalid. The inference just doesn't work here. All right. We're continuing with these all arguments that involve all statements. We've made things a little bit more tricky because here's the therefore and a conclusion in the middle. Conclusion middle is the weakest way to argue, and it's often the hardest to recognize. So indicators, therefore, because. I'm not going to bother to classify them as premise or conclusion. So now the conclusion is that Fido was a mammal, and then the other two statements are the premises. All dogs are mammals, and Fido is a dog. And again, this is valid because it's got that structure of three inclusive categories, right? So, or two categories in an individual. So you've got the category of mammals, and then the category of dogs, and then Fido is in it, right? So that's a valid structure. No matter what words you use here, that structure is valid. Okay, I'm not going to do all of these. I'm actually going to skip down now to 7, and the answer sheet will be online, and you can use that to check your other answers. Okay, 7, if George Washington was assassinated, he is dead. George Washington is dead, therefore George Washington was assassinated. Conclusion last. I'm not doing much to fuss around with structure here. GW was assassinated. And again, that's obviously a false conclusion. But your premise, if GW was assassinated, he is dead. And P2, he is dead. These are both true statements, right? If George Washington were assassinated, he would be dead. And he is, in fact, dead. Therefore, he was assassinated. But you've got a false conclusion. So if you've got true, true, false, you know the argument is invalid. The other thing you can see here is that the structure of this doesn't work. This is if A, then B, B, therefore A. It's backwards from the way a proper argument of this format would work, right? Normally you would assert A and then get B, but here you're going the opposite direction of the if-then statement, so it just doesn't work. So I'm going to skip a few more. I'm going to go down to 10. Like I said earlier, validity is the highest possible compliment you can pay an argument, and most arguments aren't even trying to have valid inferences. Most of the time we are just gambling on probability, and this is really what problem 10 brings out. So I'm going to switch over to a video of me doing problem 10 to show that although it's not valid, it's still a good argument. But let's just check this out. A forest ranger is surveying a park, and he says, "I can tell that bears have been down by the river because there are tracks in the mud. And tracks like these are made by bears in almost every case." So now remember, with the conventions that we have set up for this course, the part in italics at the beginning represents context. And a lot of times context won't matter, but sometimes it does, and I like keeping that there to emphasize the idea of context. Arguments occur in context. So this argument, this is an argument, and you can tell it's an argument because it has an indicator word. It's got this because, right? And that means that the first statement is the conclusion. I can tell that bears have been down by the river. We're going to drop out, when we put this in standard form, we're going to drop out the I can tell that, and we're just worried about this proposition that's about the world. We're not worried about the thinker. So we say, bears have been down by the river. We'll draw a line above it. That's our conclusion. And that means that the other two statements are premises. There are tracks in the mud, and tracks like these are made in almost every case. Oh, but wait, there's that word almost. That means this argument is invalid. Nevertheless, it looks like it's a pretty good argument. So now we're going to have to talk about a different kind of compliment that we can pay arguments. We said an argument is valid if the conclusion must be true if the premises were true. A slightly weaker compliment we can pay an argument is to say that the conclusion is likely to be true if the premises are true. So deductive validity is the best an argument can be as far as its inference is concerned. And if it's not deductively valid, but it's still pretty good, we can say that it's strong. One interesting thing about strong arguments is that strength actually comes in degrees. Validity is a black and white property. Arguments are either valid or they are not. Strength comes in degrees. How strong does an argument need to be before it's strong enough? Well, that depends on context. For instance, in the United States, in a criminal case like murder, you have to prove things beyond a reasonable doubt. Beyond a reasonable doubt is slightly less than validity. Validity is beyond any possible doubt, beyond a shadow of a doubt, they say. Beyond a reasonable doubt is about as close as this as you can get. You might be able to come up with some possible doubts, but they aren't reasonable. We will return to the question of how good an argument needs to be as far as its inference goes before it is called strong after we finish talking about the basic idea of strength, run through a few examples, and look at the homework. So, an argument can be strong. We now have three terms. Valid, sound, strong, and then we want to introduce another word, cogent. And then cogent is the equivalent of sound for arguments that are strong. So an argument is strong if the premises would make the conclusion likely if they were true. And then an argument is cogent if it is strong and the premises are true. So check the reasoning. The reasoning is good enough. We call it strong. What counts as good enough? That's going to depend on the context. In the case of a jury, you use the standard of a reasonable doubt. That's because it's a criminal trial with the defendant's life on the line. In a civil trial with a lawsuit, there are other standards like the preponderance of evidence. We'll talk about that when we get to burden of proof. In any case, we just say an argument is strong if the reasoning is good enough, and we say that the argument is cogent if it is strong and the reasons are true. So this is the full array of complements you can pay an argument. Valid, sound, strong, cogent. You need to know these terms. Okay. The difference between the world of valid arguments and the world of strong arguments also gets a name. We talk about the difference between deductive arguments and inductive arguments. Mathematics is generally pursued as a deductive science. And that's because the proofs of mathematics are supposed to be valid. Anything about the physical world, the empirical world around us, the world that we can sense, is going to be inductive. Arguments about that merely aim at strength. So Sherlock Holmes, in I think most of the instantiations going all the way back to the original, will say that that it's deduction, Watson. It's elementary. He's actually not doing deduction there. He's doing induction because it's about the physical world. So we put our terms together like this. The realm of deduction, if you're in the realm of deduction, things are valid or sound. If you're in the realm of induction, things are strong or cogent. Another common thing to say about the difference between inductive and deductive arguments is that deductive arguments are thought to only rephrase the information that is already given. So the reason why you are able to be so confident in the truth in this inference is that essentially the conclusion means the same thing as the premises. Inductive arguments, on the other hand, are thought to involve taking a risk. The conclusion is thought to say more than what the premises do. And this is easiest if you think about one of the classic examples of an inductive argument, which is a generalization. So suppose you know a couple of dogs, and your dog and your friend's dog both like cheese. You make a generalization. All dogs like cheese. That's an inductive argument because you're moving from a statement about a few dogs to a statement about all dogs. It means you're taking a risk. You're going beyond the information given. And that's why the argument could at most be strong. It can never be valid. Okay, so now I'm going to run through a few examples of arguments that can be valid or strong or cogent or sound. And then we'll take a look at the homework, and then we'll come back around and talk about things like standards of proof. All right. So here's an example of a valid argument. Start with a hypothetical statement. If the deficit goes up, then deficits will rise. Then interest rates will rise. Deficits are going up, therefore interest rates will rise. If you imagine that first statement is a perfectly verified if-then statement, then the argument is valid. It's if A, then B, A, therefore B. That is a structure that is always true. Here's an example of a strong argument. I have seen 1,000,000 swans. They all are white. Therefore, all swans are white. This has been an example of an induction for the longest time because in Europe, all the swans are white. And so when a European a Dutch guy, I think, finally got to Australia and saw a black swan. That was, you had like hundreds of years of this generalization. All swans are white. Of course they're white. And that generalization becomes false when you travel to Australia from the European perspective. So that kind of generalization about the physical world can be changed by more experience with the physical world. So here's another example of a valid argument. If the moon were made of green cheese, mice would love it there. The moon is made of cheese, therefore mice love it there. Now we've got a false premise, but it's got the same structure as the first argument, actually. And it's a valid structure. If A, then B, A, therefore B. Okay. So look at this argument. Do you think it's valid? Premise 1. If roses were green, money would grow on trees. It's an if-then statement. Premise 2. Roses are green. Conclusion, money grows on trees. It's valid. It's the same structure that we saw before. All right, I'm going to leave you with one final argument. This one is cogent. The sun has risen every morning for as long as anyone can remember. Therefore, the sun will probably rise tomorrow. You may think of the sun will come up tomorrow as as an absolute certainty. But by by the standards that gave us mathematical validity, it's not a certainty. It is merely the best we can do with inductive reasoning. And that's because all of inductive reasoning depends on a single premise, that the future will be like the past, at least a little, right? And whenever you're working off of the idea that the future will be like the past, you're dealing with inductive reasoning. Okay. For this set of exercises, you have to determine if the argument is valid, strong, or weak, and you need to explain your answer. I actually didn't write down that you have to put it in standard form. I want to go ahead and do that anyway because that's just something you should be in the habit of doing. So check this out. On 23/06/19 in 2003, 06/19 in Norfolk, Virginia, a violent storm blew through and the power went out over much of the city. So the storm caused the power to go out. Its conclusion last. P1. P2, P1, there was a storm in Norfolk. P2, the power went out. Conclusion, the storm caused the power outage. Indicator. So, all right, so this is a great example of an inductive argument that is strong, right? This isn't a perfect argument. It's not absolutely valid. There are other reasons the power might have gone out. Maybe squirrels were eating through the power lines. Maybe it was terrorism. Maybe terrorist squirrels ate through the power lines. These are all possibilities, but they're not very likely. We all know from ordinary experience that severe weather downs power lines and causes power outages. So we're going to say strong if the premises are true, the conclusion is likely. And I could spell that out further by just asserting all the details that I just did. All right, this next one awkwardly goes across the page, but that's fine. All human beings are things with purple hair, and all things with purple hair have 9 legs. P1, P2, flip it over. Therefore, all human beings have 9 legs. Conclusion, all humans have 9 legs. P1, all humans have purple hair. P2, all things with purple hair have 9 legs. Indicator, therefore, and this is clearly valid. It is a classic valid argument form. And actually, if we were studying formal logic, we would learn the names of this exact style of argument and that sort of thing, but we don't need to worry about that now. Okay, again, I'm not going to hit all of these. I'm going to hit a couple because they are ones that throw people off, and often it's because you're not clued into certain standard logical forms. So let's take a look at this one. The conclusion is that the king had 18 number 1 hits. The premises are Elvis Presley was known as the king, and Elvis Presley had 18 songs reach number 1 on the Billboard charts. So what's going on here is that P1 is asserting that two entities are the same, right? P1, Elvis is the king, and P2, Elvis had 18 number 1 hits. Conclusion, the king had 18 number 1 hits. Indicator so. This is valid. What's going on here is that you're substituting 2 names for the same thing. Substituting names is a valid inference. Actually, not in all contexts, but in this context. So the idea is that, as I said before, deductive arguments don't go beyond the information given, and that's sort of what's happening here, right? We could also say the conclusion could also be that Mr. Presley had 18 number 1 hits. Just changing the name doesn't change the truth of the proposition. So we're not going beyond the information that's given in the premises. All right, one more. Jack has purple hair and purple toenails, therefore he has toenails. Actually, the only premise you really need here is that he has purple toenails, right? And it's just a property of having purple toenails that you have to have toenails in order for them to be purple. We can do it like this. P1, Jack has purple hair. P2, Jack has purple toenails. Jack has toenails. Indicator. Hence, it's valid if you have purple toenails, you must have toenails. And again, just like the thing has to exist for the property to apply to it. And so it's a purely logical point, and that's how you can tell that the inference is valid. Okay, so I'm not going to run through the rest of these. The answer sheet is online. And now I want to fill in a few more details about what to do when you are evaluating arguments, how to go about it in a practical situation, and paying attention to burden of proof and standards of proof is going to be crucial here. Okay, so that gives us our 4 basic terms for evaluating arguments. If arguments are deductive, if you're trying to be like math, then your arguments are going to be either valid or sound. So if they're valid, the inference is perfect. And then if they're sound, they also have true premises. If you're trying to be inductive, which is the way we work in most of the real world, your inference can be strong. And then if the premises are also true, the whole argument is said to be cogent. Now, I want to talk about the practical business of applying these terms in the real world. So, the key thing that we're going to use when we evaluate arguments is called an argument scheme or an argumentation scheme. So this is kind of an elaboration of the standard form that we've already been putting arguments in. An argumentation scheme is a established style of argument that has certain virtues and drawbacks, and they're going to be a set of what we're going to call critical questions to ask and reply. So the argumentation schemes are like different subtypes of standard form. The critical questions then are things that you ask whenever you have analyzed an argument once you've put it in standard form and then one of these subtypes, perhaps. So some critical questions could be asked of any argument, while others only go with certain argument schemes or specific forms of argument. Okay. The critical questions that go with any argument are just the ones we've been talking about so far. So we said check the premises, that is, check the reasons. Are the premises true? Or at least, are they plausible? You also want to check the reasoning, check the inference. Do the premises support the conclusion enough in the given context? And then the third question, has any relevant information been omitted from the premises? Now, actually, I've changed the wording here because we're getting more applied from what I was talking about before. For instance, here I say, are the premises true or at least plausible? This is because there's a question lurking here. How much time do we want to spend confirming the truth of the premises? People are going to throw things at you all the time. So you have to ask, how important is the issue that I'm dealing with? And how much time do I want to devote to confirming the truth of the premises? Same thing happens with the strength of the inference given the context. This is, again, the question of how strong is strong, right? How strong an inference do we need in this context? So now I want to return to concepts that you might be familiar with from the law, or at least from lawyer shows or true crime shows. So these concepts are the burden of proof and the standard of proof. So one of the things that people will say all the time in the context of the US legal system is that you're innocent until proven guilty. That means that the burden of proof is on the prosecution. They are the ones who have to prove their case. In general, we say that the burden of proof is the obligation of one side of a debate to prove their case. The burden of proof is on the prosecution. They have to do it. And if the burden is not met, we say in American legal system that the defendant is innocent. We could also say that the case is undecided, but that's not the way we do it in the legal system. Either way, you can ask whether who has the burden of proof in any given argument? Whose job is it to prove their case? And like I said, in a criminal court case, the burden of proof is on the prosecution. The standard of proof is the amount of evidence that the party with the burden of proof must produce. And so again, this should be familiar with you. The burden from the US law, the burden of proof is on the prosecution, and the standard of proof is beyond a reasonable doubt. It is up to the prosecution to take on the burden of proof, prove their case beyond a reasonable doubt, otherwise the defendant is innocent. So there are other ways to handle standard of proof than the way the US legal system does. We already mentioned one, right? Deductive validity is a standard of proof. It is the standard of proof that is used in mathematics. And on this standard, there is no possible way for the premises to be true and the conclusion false. So that's actually higher than the standard of proof that we get in legal court. And, that is because in real world situations, if you're not just talking about numbers, it's always possible to invent weird scenarios. The killer, I didn't do it. The person was killed by space aliens. That's not a reasonable doubt. That's an unreasonable doubt. The weird thing about math and pure logic is that they're not any more unreasonable doubts. It's all supposed to be deductive. So another standard of proof that I want you to be aware of is the preponderance of evidence standard. And this is actually weaker than the criminal court standard. This is the standard of proof that is used in civil trials, like lawsuits, when you're suing people for money. And here we just say that if the premises are true, the conclusion is more likely to be true than not. The preponderance of evidence, the majority of the evidence, is on one side or another. 51%, roughly, right? Now, we're familiar with ideas of standard of proof and burden of proof from legal cases where they're fixed constitutionally. But in informal situations, we often lose track of where the burden of proof is. So a common tactic in informal argument, people arguing on the internet, people arguing in in bars, ordinary circumstances, is for them to try and push the burden of proof off on you when it's not really on you. So this is really common with people who believe in unusual, well, things like UFOs or ghosts or paranormal phenomena, things that can't be tracked by science. They claim explicitly this is beyond your science. The Ancient Aliens guy on the History Channel. The main tactic that they use is they shift the burden of proof from them to you. You can't prove that the pyramids weren't built by aliens. In general, the thing to do here is to just walk away from people who are daring you to disprove their crazy theory. I say that the president of the United States is a gray space alien. Well, the old slogan from Carl Sagan applies. Extraordinary claims require extraordinary evidence. The burden of proof is on them, and the standard of proof is high. And if they're not going to do that, just ignore them. So this gives us two key fallacies that we keep track of in the traditional approach to critical thinking: burden shifting and appeal to ignorance. Burden shifting just is what I was describing. It's the fallacy that's committed when someone tries to dump the burden of proof on you when really it's on them. You can't prove me wrong. Appeal to ignorance is a specific kind of burden shifting where people say, well, it hasn't been proven true, so it must be false. And these definitions are not precise. They're mostly just here to point you to the general, a general warning. Don't let people push the burden of proof onto you. So we got on this topic of standards of proof and burden of proof because of the questions, the critical questions that go with any argument. Are the premises true? Do the premises support the conclusion? There's a secondary question with each of these. How strong does the support have to be? How well confirmed do the premises have to be, right? So now I want to return to the critical questions that go with critical questions in general, and talk more about specific styles of argument. So the critical questions are questions that we can ask once we've put it in standard form. And if we put it in one of these sub-styles, these argumentation schemes, there are additional critical questions that we can ask. So this semester, we are going to look at 4 styles of argument: argument by analogy, argument from authority, inductive generalization, and the instantiation syllogism. And for each of these, there's going to be a specific way of putting it in standard form. It's not going to be the usual, it's going to be a sub-variation of the standard form. And for each of these styles of argument, there's going to be a characteristic fallacy. Now, remember that a fallacy is an argument that appears to be good, but is not. So when we talked about burden shifting, that was a way to make your argument seem better than it actually was, right? So fallacies are common mistakes in reasoning. One of our styles of argument is we're going to call inductive generalization. This is just what happens whenever you move from a small number of cases to a more general statement. So there's a fallacy that goes with the style of argument the argumentation scheme, inductive generalization. We call it a hasty generalization, right? So this is a fallacy when one moves too quickly from a premise about a few examples to a conclusion about a large group. Here's an example. Bob went to the store without Bob went to the grocery store while wearing a mask. Bob later got COVID. Everyone who wears a mask will get COVID, right? It looks like some of this reasoning is going on with bad reasoning around the pandemic. So we're going to have a scheme for generalizing, and there's a fallacy associated with it, the hasty generalization. There are also going to be critical questions that are specific towards generalizations. And if you can't answer these critical questions, you will be committing the fallacy of a hasty generalization. And actually, to generalize really well, you have to use the techniques of statistics, at least a little bit. So the two critical questions for inductive generalization are, is the sample large enough? And is the sample representative? So that's what we're going to be covering for the remainder of this section. We're going to be looking at these four argumentation schemes. And actually, the next one up is not inductive generalization, it is argument by analogy. So what do you need to do for class 9? The pattern for class 9 is reading exercise video, then reading exercise video. So I want you to do a reading, do an exercise on the reading, watch the video, and then repeat. Great. This is a really fun part of the course in my mind because it is, well, this is what we call real philosophy. You know, this is the standard ordinary reasoning, and I still think this is fun. All right, thank you.